All right, so welcome everyone. So my name is Carey Payette, and do not use that Discord link. Instead, what you want to do is go to the StirTrek website again, go to the schedule and hit refresh on it, because sometimes your devices will cache. And there should be a new link for Discord up there, so if you have any questions or want to reach me after the fact, feel free to use the Discord link that is there, not there. So hello and welcome. So here we're going to be talking about an introduction to Azure Infrastructure as Code. So I am Carey Payette, and I am a newly branded HashiCorp ambassador, so still learning the ropes of what that all means. But I'm absolutely love the product, so it's part of the reason why I'm doing this talk. I'm also an Azure MVP as well as a Microsoft certified trainer. So during the session, what we're going to do is we're going to delve into the significance of infrastructure as code. So basically learn why it's important to include infrastructure as code within your continuous integration, continuous deployment pipelines. And we're going to also explore a handful of tools. So this is not going to be one specific tool. We're going to actually go through a few of them. In particular, we're going to go through ARM templates, Bicep, Ansible, Terraform, and Pulumi. So ultimately what the goal of this session will be is that I want to be able to equip you with a taste of multiple tools so you can see exactly what works best for you and your organization. So there's not one tool that I'm going to cover today that is bad. They all have merits. They all do similar things. It really comes down to a fit for your organization. And hopefully after just having this general taste of the technologies available, that you'll be able to decide what works best for your company. So here's a quote that I like. So I bring this up for most of my infrastructure as code talks. And it comes from Rekha Mahesha, who's an author with Pact, and it says, infrastructure as code, also known as programmable infrastructure, is a process for managing computing and networking infrastructure using software development methodologies. These methodologies include version control, testing, continuous integration, and other practices. So that is probably the best definition that I have seen that really compartmentalizes exactly what infrastructure as code is and the benefits for it. So let's go ahead and get into some further details. So some of the benefits, again, you're going to have full SDLC tooling. So what this means is that ultimately what you are creating, the assets that you're developing, are code, so they can be managed just like any of your other software development projects. So the entire coding ecosystem is available to you. So this involves things like source control, GitOps, CI/CD, Azure DevOps, for instance. What's also nice is how many people here have awesome documentation in your organizations? I don't even see one hand go up. So that is another reason for infrastructure as code. So infrastructure documentation is the code. So when you're trying to think, okay, what do I have deployed into production, you don't have to go find a Word document that was stale 15 years ago inside of a network share, for instance. You can actually go to your repository, take a look at your infrastructure as code, and you will see exactly what you have deployed. The system documentation is there. Another thing is correcting environmental drift. So another situation that we run into a lot is that, half of the organization is awesome with doing infrastructure as code, and they have their assets in source control and have full processes around it. And then, you have Guy B that comes in and says, oh, I'm just going to go start creating resources in Azure, right? And not documenting it. So what's nice is a lot of the tools that we're going to talk to you about today have ways of correcting environmental drift. And the environmental drift is, I wouldn't call these people rogue people, but not as structured people that are creating rogue assets, for instance, inside of your cloud environment. So essentially what happens once people go and create these resources, you end up with something that's called a snowflake. So what it means is that a unique configuration is not there. you need to correct that environmental drift so that you have that repeatable process to make sure that you have exactly what is in your infrastructure as code is what is deployed to the environment. So deploying identical environments. So I used to, I'm a software dev at heart. So I used to be, thinking that I was, top of the world. I was the best, right? Because I could go out and deploy these web applications in the Azure portal, and I knew it. I had it down to a science, right? Click, 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 submit, done. Go back, do these resources, set this connection, blah, blah. I could have it up in an hour. That was fantastic. And then somebody will say, well, I need a test environment, and I need a production environment. How do I recreate that, right? So then I would go back to the Azure portal, because I'm a ninja, right? So I'm going to go to the Azure portal, and do the same thing. Then I forget to set a whole bunch of settings, right? Because it's not a repeatable process even though if you could be totally awesome with the Azure portal, it doesn't help you deploy identical environments. What's nice with infrastructure as code is you have that definition. You could set some parameterization, and you're able to say, okay, here's my dev environment. Okay, now I need test and production. Okay, change a few parameters. Boom, it goes ahead and does the thing, creates the identical environments for you, thus avoiding like some of the errors that you would have for hand tooling it, as well as being a lot more efficient. So environmental consistency, the same idea. I forgot to go back and apply certain settings. What's nice is that you could have these deployment configurations available in the code and automated, so again, you don't have that error. Speed. Again, infrastructure as code is a force multiplier when it comes to this. What that means is that the tools themselves can determine which tasks can be run in parallel. So if I'm going to the Azure portal, I'm creating this, it's all synchronous, it's all like one thing at a time. But if I go and submit, say, here's 3 resource groups, each has a SQL server and each has a storage account, I can go ahead and trigger that, and the Azure Resource Manager will go through and create all the resources groups in parallel, create the SQL servers, and essentially be able to judge for itself the efficiency that's needed to deploy those resources in an effective manner. Lower infrastructure and management costs. Again, this comes back to that documentation. So I do understand, and trust me, the Azure calculator is, I'm afraid of that thing, but at least with infrastructure as code, you can actually see here is the summary of the resources that I have, the different SKUs that are available, and you can somewhat use the Azure calculator to see what the cost is, so you can definitely control and monitor your spending that way. All right, so what is the truth? And you can handle the truth, right? So one thing that I had to do when I started entering the infrastructure as code journey was kind of turn things on its head. So I used to think, okay, well, what's in production, that's the truth, because that's what's actually really, really there. That's what's really deployed. And I had to kind of flip that on its head a little bit and say, well, I want the code itself. Again, that code is your documentation. That code is what is your end state. I need to flip that on its head and think of the code as the source of truth rather than being what is actually deployed. So what you're ultimately doing is when you're designing your systems, your infrastructure's code assets will let you dictate the end state of the cloud infrastructure and not vice versa. Another thing too is, like, if you have some pet project that's only going to be short-lived or something, even though it's really fun to do, you don't necessarily have to put every single little thing in infrastructure as code, right? So don't feel that it's an end-all, be-all. Use it and apply it as it makes sense in your organization. Again, make the code the single source of truth, but some of the benefits here is the source control. So you're going to have ultimately the history of what was developed for your infrastructure. But what's also nice, too, is that when people accidentally break things or if people accidentally add things in, you can actually go through the version control and say, hey, well, so-and-so, you did this on this date. You have somebody accountable for that. Not saying that you use infrastructure as code as a way to, hunt down people that make mistakes, but it's also a great learning tool to say, okay, you made this mistake, this is what happened. Another thing with source control as well is that you can have gate checks. So you can have somebody review things before your CI/CD pipeline, for instance, gets engaged to deploy that code, so you can catch those errors early. So anything that you're using right now for your software development projects for version control is just as valid for infrastructure as code. So here's the continuous integration, continuous deployment. So CI/CD stands for continuous integration, continuous deployment, and it's a very common practice for software development. So continuous integration means that you're frequently integrating your code changes into a shared repository. So essentially what you're doing there is you're detecting and fixing integration issues as early as possible in the development cycle. And this is achieved, again, through automatic builds within your tooling of choice whenever code is committed into the repository. CD is continuous deployment. So this is where IAC really shines, and it's the practice of automatically deploying software to production or other environments that have been built and tested. So again, what you're doing here for CD is you're reducing the time to deploy things to different environments, and things are deployed in a consistent and reliable manner. So together, CI/CD provides that streamlined approach for software development, for infrastructure as code, where changes are automatically built, tested, and deployed. Again, reducing risks of errors, improving speed of the quality of the systems, adding automated testing frameworks. So again, at the end of the day, what I want you to take away here is that infrastructure as code is treated just like software. It is code. It's checked into source control. It's built, tested, and deployed, all in the same consistent way as your software development environments. And then again, the managing infrastructure of code reduces that risk of error and downtime. All right, so some of the tools of choice for CI/CD pipelines. And again, this is just a sampling. So there's many tools out there, but I do want to call out a few of them. So Azure Pipelines, so the pros, again, if you're using Azure DevOps right now, it supports a very wide range of libraries and platforms. It has things like release management, it has deployment gates, so again, those approvals, and it also has multi-stage deployments. Some of the cons are that you're limited to support, it has limited support for on-premises deployments, and it can be complex to configure for some different environments, some scenarios. GitHub Actions, pros, like if you are using GitHub-based repositories right now, it supports a wide range of languages and platforms, so I'm sure a lot of you are familiar with GitHub already. It also has features that include things like workflow visualizations, reusable actions, and matrix builds. Some of the cons, again, you're limited to GitHub repositories, and it's still relatively new compared to the other items that I have on the list here. So Jenkins has been around for a long time. It's highly customizable. It supports a wide range of plugins and integrations. It can be deployed on premises. It could be deployed on the cloud. But at the same time, the cons for this is it can be quite complex to configure and maintain. And because it's been around the block for quite some time, a lot of the plugins that you will find are outdated and may not just work anymore. So it's kind of hard to find things that really work. So really, at the end of the day, in general, Azure Pipelines is a good choice if you're using Azure DevOps, GitHub if you're using GitHub Actions, or GitHub for source control, I should say. And then, of course, Jenkins is if you have a need for a very high need of customization and control over your CI/CD pipelines. So at the end of the day, what we're going to be talking about is the actual deployment of Azure infrastructure. So I wanted to touch a little bit about how Azure deployments actually work. So the root of it all, Azure Resource Manager, that big box in the middle, This is what manages all the resources within the Azure portal. So every resource that's created, destroyed, configured, edited, it's orchestrated through that Azure Resource Manager. So to deploy the resources, you're probably already familiar with the different methods, but you have things like you can use the Azure portal, you can use the CLI, you can use PowerShell. But at the end of the day, what happens is the Azure Resource Manager exposes a REST API. So these REST API endpoints are what enables the development for these third-party tools to aid in the deployment of your infrastructure. So the Azure Resource Manager uses what's called a provider or plugin model. So that means that as services are introduced into Azure, essentially there's a provider that can be registered. So I don't know if any of you have done the cloud deployments where you've gone into a new subscription and you tried to deploy a storage account, for instance, and it said, well, you need to register the resource provider Microsoft.storage. And then you would have to go into the Entra settings and say, okay, Microsoft.storage and register that, and then it becomes available to the Azure Resource Manager. So that's that plugin interface. So essentially all of those plugins, or like Microsoft Storage or Microsoft.SQL, for instance, those providers adhere to that common interface that gets orchestrated through the Azure Resource Manager. So one thing to note here is that when a new type does get created inside of Azure, so some new Fandango, silver, gold, shiny technology comes out, as soon as that resource is available in Azure, it's automatically included in Azure Resource Manager. Again, everything goes through Azure Resource Manager. The problem is, and it's not really a problem, is that third-party tooling support tends to lag behind. So unless people have like that pre-build access, for instance, it might take a little while for a third-party tool to catch up with that new technology. So that's expected. Another thing to note here is that you might have an infrastructure as code definition. What I want you to think about it is that it's a configuration. What you're doing when you're developing your IAC assets is you're creating what you see as your end state. So if you create 2 resource groups, 2 storage accounts, 2 SQL servers, you're saying that this is your end state. I want those resources to be there. Again, this is going to reflect and be your documentation for your environments going forward. If you rerun that definition over and over and over and over again, so say I take those, I have like 1 storage account in a resource group with a SQL server. If I run it 30 times, because it's defined as your end state, the Azure Resource Manager will take a look and say, oh, this already exists, and it'll skip by it unless there's a change to be modified, right? So idempotency is what's important here. So you don't have to worry. You can run through your continuous integration, continuous development. You can run the deployment over and over every time code is committed, and things that were already there, as long as there's no change, they'll still be there. All right. So it's not going to, add things to the tally. So another thing that I want you to understand here is a lot of the third-party tools that we use the Azure Resource Manager in what's called complete mode. So if you go through and you have some code and you decide, okay, well, I'm going to take this SQL server out of this infrastructure's code, and then you commit it and the build runs, the Azure Resource Manager is going to say, okay, well, the state before had the SQL server, it's not there now, so I'm going to go ahead and delete it, right? So you have to be careful too, because I've known some people that have, accidentally removed key vaults, and that is not a good thing in a production system. So do pay attention to that. Another thing to note here is that the dependencies. So the order that you describe or configure your resources in your infrastructure as code doesn't matter. So even if I put the resource group after the storage account, for instance, the tooling will identify those dependencies for you. and you don't have to worry about saying, well, this has to come first, and this is second, and this is third. So you have configurations like public IP addresses that you might need to add to a firewall, for instance. There's no chicken and egg issue. It doesn't really matter where inside of your code that these dependencies are created, that the tooling itself will identify what those dependencies are and make sure that things are done in the proper order. So you don't have to worry about that situation. All right, so the last thing I want to talk about on this slide is a lot of the tools that we're going to cover today also have various levels of import functions. So if you're just starting your journey right now with infrastructure as code, you have the ability to use some tools that'll say, here, point me to like a resource group, for instance, and generate the IAC code for the resources that already exist there. So just because you might not have infrastructure as code in your organization at this time, it shouldn't be a barrier for you to get caught up if you identify those various systems as benefiting from infrastructure as code. Some overall guidance for getting started. Don't boil the ocean. So you don't want to take your largest, most complex system that nobody understands how it works for your very first project. So what you want to do for a candidate for a project is identify things that you do over and over and over again. So if you're a .NET shop, for instance, you might have a resource group with a storage account and a SQL server and an Azure web app. And this is something that you're consistently doing over and over and over and over again. What's nice is you can identify those patterns and create reusable modules inside of your tool of choice and basically parameterize them. So every time you have another system comes down that fits that model, you can just throw in different parameters, and you would have a standard deployment then that would take over and do the actual deployment for you. Another thing to keep in mind is that you want to develop standards. So what I like to recommend here is that if you don't have somebody that's already versed in infrastructure as code, that you do take some time to learn it through mentoring. So I would recommend having a contractor come in that has that type of experience to provide some guidance there. So what they will do is help you learn how to split things up for various modules, make sure that things are well defined, and make sure that you put the proper architectures in place. Another benefit to having IT staff or consultants that are experienced in IAC is that because infrastructure as code, it is not immune to spaghetti code. You can get some pretty nasty infrastructure as code setups. So again, having that mentorship is very important if you're just getting started. So luckily for us, again, what we're going to do here is avoid a lot of the spaghetti code, because the tooling that we're going to cover today, a lot of them support modular and composable infrastructure. So that means that you can have large, complex infrastructure broken down into the little bits and smaller units of code. So this will make it easier to maintain, easier to read, and of course, reuse. So another thing I want to cover here is that a lot of the tools that we're going to cover today, they're all good tools. There's not a bad tool. Again, find what is best for your future goals as well as the skill sets that you already have in-house in your organization, and to choose a tool appropriately. So some of the infrastructure as code options, there's a couple different ways of approaching things. So one is a declarative way, and one is the imperative or procedural way. So declarative, it's more like you're creating metadata assets, if you will, that describe what your configuration is, whereas the imperative or procedural is typically like if you might have a PowerShell script, for instance, that you develop that deploys like all the infrastructure that you need for your Azure web app, for instance. So you can have scripts automated in your CI/CD pipeline in PowerShell if that is what fits your skill set and that's what fits your organization at the time. So not everything has to be declarative. Things I'm going to show you today are primarily the declarative ones. But really the best way to distinguish between the two is that a definition file, so the declarative way of doing things, is what an environment requires, whereas the imperative procedural approach is the how. So the how inside the declarative models are pretty much offloaded into the tools that you're going to use, whereas the how for the imperative and procedural, you're going to be doing that on your own, like writing PowerShell scripts, for instance. So, all right. So here's a scenario right now. So what we're going to be doing over and over and over again as we look at these tools is we're going to be deploying an Azure static web app to Azure static web app from a GitHub repository. So I have this GitHub repository that is public, and it's not really amazing. So if we go into this HTML, you'll see that it's just a regular run-of-the-mill HTML file that says, welcome to infrastructure as code. So that is what we're going to be deploying through these tools. Again, not so much that we're worried about what the website is and the actual deployment of code. What we're interested in is getting a feel for how the actual infrastructure is deployed. So we're going to use this scenario in each of the tool demonstrations coming up. All right. Apparently we're going to do the video again. So the first part, and again, the first stop on our journey is ARM templates. So ARM templates ultimately are always guaranteed to be up to date because this is literally the language, I guess you could say, that the Azure Resource Manager uses. So when you use the Azure portal to manually configure a deployment, it gets munged down essentially, and an ARM template gets created in the background and submitted to the Azure Resource Manager. So you have the ability to export ARM templates from existing resources. You can also export ARM templates from resources that you are deploying. So some of the pros here, it's native to Azure, so it is integrated with Azure services and Microsoft tools. It's easy to understand, especially if you have the skill set that you're comfortable reading JSON-based documents. And it has excellent documentation. So Microsoft did a bang-up job for documentation there. So some of the cons here is that you have limited support for debugging. You have limited support for conditional logic. So I'm not saying that you can't do that, but it's limited. Limited support for testing. And then you also have limited support for modularization. So ARM templates actually have a way of modularizing, which basically has a way to use something called nested templates. And basically what you do with nested templates is that you can break things up into smaller chunks and then include them within other templates. All right. So the first step here is that, again, the building block is an ARM template. So rarely do you ever have to build these from scratch. I always like to do, like as I'm going through my demos here, I like to go through the Azure portal, say, well, I want to know what a template looks like for deploying a virtual machine, so I'll go create a virtual machine, set things up, and then once I deploy that, I'm going to be given the option to, well, you don't actually have to deploy it, but you're going to be given the option to download the template. So as I go through this, typing in these settings here, you'll see in a moment that I'm able to download the actual template that is the resultant of creating this virtual machine directly in the Azure portal, and that gives me that starting point. So I'll hit review and create, and then you'll see down here on the right-hand side, it says download a template for automation, and that will allow us to take a look at the actual template, look at the parameters file that's there. You can see that, create a VM that has multiple resources that are there and multiple variables and parameters that you can set. So that is that one. All right, so I mentioned earlier that we have the ability to also export templates. So again, this is kind of, well, I called it import, but essentially if you already have infrastructure and you decide that you want to extract the ARM template for the existing resource group, you can actually go into the Azure portal and you'll see that here's my static web app. I'm going to go down to export template. And then this is where pre-recording the demos is nice, because 18 seconds later, you'll see that I now have a template that's available to me to download that consists of every resource that is in my resource group. So there's my static website, and it had some basic auth settings associated with it and some parameters. All right, another situation that you might find yourself in is that you may be given an ARM template. Well, what do you do with that? Well, one option, of course, is to go and deploy it inside of the Azure portal itself. So you would go up to the search bar and you could say, deploy a custom template. So I'm going to go ahead and grab that. And we'll say build your own custom template, and I'm going to go into Visual Studio Code here. And this is an Azure deploy.json, which is essentially an ARM template that contains the resources of the static web app. So you can see here's the resource, this is a static site, and I can hit save. And then I also have the ability to add the parameters. So I'll go back into my Visual Studio and show the parameters file, and you can see that I have the location as East US 2, the value is free, and once I've uploaded these values into the parameters, I can go ahead and hit save again, and then now when I go back to my form, you can see that all the fields are filled out. And then lastly, the other option is obviously when you're trying to automate things, you're very rarely going to go out to the portal, but you do have the option of testing things out with the CLI. But all of the test runners also have like steps or actions to run like ARM template deployments. But if I were to do this one directly from the CLI here, you'll see that I have my Azure deploy.json that shows, again, the same one that we put in the portal just a moment ago that has my static website. And I can go ahead and actually run the Azure deployment directly from the CLI. So this one is actually using Bash. So I tried to also throw in a few different technologies in there. So the first thing I need is a resource group. So I'm saying AZ group create vanilla web app RG. And you'll see it went out and it created that resource group. Just going to refresh the button a whole lot of times that we don't have to sit through. And you'll see that the resource group gets created. And then I can go back and deploy my actual deployment, which is that Azure deploy.json. And I'll show you here in a little bit more detail in a moment. But you're going to create a deployment group, going to give it the resource group, the template file, and the parameters file. So it's going to go ahead and run and do its thing. And 18 seconds later, you're going to have resources inside of the resource group. So I'm going to go back to the Azure portal, and you can see our vanilla web app is there. What's really nice about deploying with the ARM template is because I do have it linked up to GitHub, it automatically created a GitHub action for me, so I can go and see that the GitHub action is already created there. And it's going to go and run to completion. So the way that this GitHub action looks, it's a YAML file, but essentially what this is saying is every time code is pushed into main, it's going to build and deploy my static web app. So it's going to use a web API token here. So this is my static web apps API token, yellow smoke, blah, blah, blah. The resource token, the GitHub repository token, which is essentially a personal access token that is assigned to it. But essentially what happens is that it will have the credentials added automatically to deploy that. So we'll go and click on yellow smoke here in this case, and you can see that welcome to infrastructure as code session gets deployed inside of that Azure Static Web App. And then this is just showing that it created a repository secret for me automatically. So let's go ahead and take a look at Visual Studio Code just quickly. And you can see here that we have our Azure deploy parameters. And what I did was I added that repository token. And again, this is already dead, so you can copy it all you want. So I'm not doxing myself. So, but I've added a repository token so that I'm able to do that deployment, and I'm giving it a parameter here for the Azure Static Web App as well. And then essentially inside of the Azure deploy, I'm going to have a listing of those resources, but really at the end of the day, it's the Azure Static websites, and then I'm allocating the repository URL, the branch, and some properties. So again, I just want you to get a feel for, like, hey, this is JSON-based, this is what it looks like, this is what it feels like. You don't necessarily need to take away, okay, I have to know the specific way of deploying. Each resource has very good documentation over what properties can be set on them. All right, so let's go back here. All right, so the next item that we're going to talk about is Bicep. So Bicep is a newer infrastructure as code option for Azure, and it provides a more streamlined or more simplified way of defining Azure resources. So Bicep in itself is a declarative language that allows you to define the infrastructure. And I find it a lot more clear and concise versus JSON, but again, that's my preference, that's my opinion. Your opinions may differ, and that's fine. So Bicep is open source, and it's designed, again, to improve the experience over hand-tooling these ARM templates by providing more simpler syntax and a more intuitive structure. So some of the benefits here that we have include simplified syntax, improved modularity, better tooling. So you're going to get things like code highlighting. You're going to get completion, auto-completion, so like IntelliSense. You're going to get error checking. So it makes it easier to write debug code. Improved error handling, too. So Bicep provides a lot more informative error messages compared to ARM templates. So again, it makes it easy to identify and fix errors. But again, because at the end of the day, everything gets compiled down to ARM, Bicep itself is not immune to some of the drawbacks of ARM testing. While you can do testing on Bicep files, it is limited for debugging. And the documentation, not the greatest. So I actually tend to use the ARM documentation while I'm writing my Bicep code. So Bicep, again, in my mind, it simplifies that ARM template syntax. So it's a great tool to use when you're getting started, when you're getting started with IAC. But also, Bicep Playground is a nice website. So it's azure.github.io/bicep. What this allows you to do is take any existing ARM file that you have, and it decompiles it into Bicep code for you. So I'm going to go ahead and play this one. So here you can see that we have our Azure deploy. This is the exact same template that we saw in the previous demo that has our static website. But what I'm going to do is I'm going to import this into the Bicep Playground, and this will allow us to upload our Azure deploy file into this interface. And then what it does is it takes a look at it and spits out on the left-hand side the Bicep code that would be associated with that ARM template that we have on the right. So you can think about it as you can go into the Azure portal and you can export like a resource group, for instance, and you can run it through this tool and be able to get the Bicep code, resulting Bicep code available for you. So again, great tool to have in your back pocket. So the next way of deployment, I'm going to use, instead of Bash, we're going to go with PowerShell in this case. So you can see I still need to create a resource group. So I'm going to create vanilla web app BICEP RG in East US 2. So it went ahead and succeeded, and I can go to the Azure portal, refresh it a couple hundred times because caching is a thing. So eventually the vanilla web app Bicep resource group will show up, and then I can go ahead and do a deployment. So the syntax is very similar to the CLI that we saw in the previous demo. It's just basically a different way of approaching it. So about 10 seconds later, we have this message that comes up saying, okay, Bicep, which is installed by Chocolatey, by the way, it identified that in the state that my cloud is right now, that those resources don't exist, so it wants to go and create these 2 items. I tell it, yes, go ahead and do the thing. And 1 minute and 24 seconds later, we're going to end up with the resources deployed to our resource group. So I'm going to go back out to our resource group here, and we'll see that we do have our static web app, and it's going to be exposed through Blue Water, for instance. But of course, similar to ARM, what has happened is that an action was created, so it's going to actually do that deployment for me. So I didn't have to create this workflow file. It did that for me, so I'll go ahead and open up the deploy job. But again, what's really nice about GitHub Actions here is you can actually dive in and see the status of what's running at a given time. So you can see that it's zipping things up, it's uploading artifacts, it's published the deployment, and then eventually you're going to have the actual workflow complete. But what's really nice, again, using a lot of these tools is that you can get the full output of the deployment of your infrastructure. So if something fails, you can go and take a look at these logs and identify what went wrong. So now that the action has completed, I can go out to Blue Water, and you can see that we have our welcome to infrastructures code. And then, of course, with settings, and I go down to secrets, obviously I cleared out the ones from the previous demo, but you can see that we have our Blue Water token that was created automatically based off of the parameters that were sent in through the Bicep code. So let's switch over here back into Visual Studio Code and take a look at the code. So you can see that, again, I have, so this was just for the uploading to the playground, but I have this main.bicep. And what I did, was provided Bicep code that would point to that repository and deploy a static website. So it's basically resource name is Microsoft.web static websites, and then the @ here will be the API version that the REST endpoint uses ultimately. So you can see that I create that resource, I set the repository URL, and I use the repository token, which is a variable that is described above. And I also added configuration that had some app settings that were also provided in the parameters. Now, before Bicep used to only support like the Azure deployed JSON parameters, but more recently, they started having their own Bicep param file, which is, again, an easier way of declaring over JSON. So you can see the main requirement is that top line. You would say using main.bicep, you have to associate a parameter file with an actual Bicep file. But you can see the different parameters that I added here to populate that deployment. All right, so the next one is Ansible. So Ansible has been around for a very long time. So it uses a declarative language, again, using YAML to define the infrastructure, services, resources, and configuration. So when you're talking about the YAML with Ansible, you would refer to them as playbooks. So a playbook essentially outlines a series of resources and actions that need to take place. So for simplicity, so some of the benefits, again, for infrastructure's code with Ansible is simplicity. So it's a simple syntax. You can see it here on the right-hand side. We have variables. We have tasks. So I find it's easy to write. It's easy to understand, and it's accessible for many users of different levels of experience. Some flexibility. Again, Ansible can be used to manage your infrastructure for a variety of environments, including on-premises, in the cloud, and in hybrid environments, so it can be used anywhere. Scalability, so Ansible can be used to manage infrastructure at any scale. So we've seen some really enormous systems developed with using Ansible as an infrastructure tool. And of course, reusability. Those playbooks can be reused as needed across multiple projects. So again, from an organizational procedural perspective, you want to identify those patterns that you repeat over and over and over again inside of your projects, inside of your organization. So create playbooks for those, and you're off to the races. So some of the cons here is that it does not have support for all Azure resources. So out of all the tools here, I find Ansible is probably the one that tends to lag the furthest behind as things get introduced into Azure, for instance. So case in point, the playbook I'm going to show you here today does not include the deployment of a static web app. It's actually going to create an app service plan in Azure web app because there isn't a playbook currently to support static web apps. Now, there is a way around it. You can create a playbook that will automate the CLI. So if you wanted to do CLI deployment through an Ansible playbook, you can do that. And another, I wouldn't call it necessarily a drawback, but Ansible requires a Linux-based control node or runner. So in my case today, I'm going to be running a Windows subsystem for Linux 2 or WSL2, and you're going to see that from the demo here in just a second. So let's take a quick look at the code for the playbook that we're going to do right now. So obviously this one's going to be a little bit bigger because we're going to be deploying more resources in this case. So I'm going to open up my Ansible YAML here, but you can see I really like how it's structured. So we have name, host, connection, gather. We have our variables here. We have tasks. I can say create the resource group. It uses Azure RM resource group, passes in the name, location, and so on. So what's really great here is I don't have to create my resource group. This will actually automate it for me. And you can see here that I'm deploying a resource group, an app service plan, and an Azure web app. So let's go back to our presentation, and we'll play this one. So you can see here is the items that I just showed you. So let me, hopefully I didn't spend too much time with that. There we go. And I'm going to say Ansible playbook Azure deploy.yaml. And then you can see that it's going to go ahead and introspect it. But what I want to call out here is that I am using the WSL terminal. So you can see that right here in the demo up here, it has WSL. But you can see that it's going step by step through the tasks that I defined and deployed those 3 items into the Azure portal. So I'm going to refresh that and go back, and you'll see that we now have an Ansible resource group, and basically the same item. It created the app service plan, and it created the Azure web app. All right, so the next thing that we're going to talk about is Terraform. So Terraform, I'm not going to lie, is my favorite. So I might be a little biased here. But what I like about Terraform is that it does have a domain-specific language, so similar to Bicep. But what I like is the structure of it, the way that it's modular. For me, even the strong community support. So the community around Terraform is just amazing. And another system that has absolutely fantastic documentation for when you're deploying items. So you can see here that I have this code snippet here on the right-hand side. It's going to deploy a resource group. It's going to deploy a static web app. And then as the output, I want to make sure that I see the API key. So one of the things that this does not do, and again, we're worried here more about the deployment and the infrastructure, not necessarily the code in this case, because the code is usually a separate pipeline. It will not automatically create the GitHub action like it did for the Bicep and the ARM. So what I'm going to do here is I'm going to output this API key and I'm going to use that to update my GitHub actions. So essentially, when you're deploying into an Azure Static Web App, you would deploy, the key identifies what resource gets updated, essentially. So all I have to do in order to have that pipeline is keep the action from the other demo and update the key. So let's go ahead and run this one here. So here's our Terraform deployment. We have a resource group, we have the static web app, we have the static site key. And I'm going to go in and I'm going to say, okay, Terraform init. And what happens here is that, I'll show you here in a moment, is I've said I want to use the Azure RM provider. And what it does on the init is it actually goes out and it pulls down this executable. And this executable is written in the Go language, which essentially is responsible for doing all the interfacing with the Azure Resource Manager. So the next thing you can do is plan. So you're not ready to apply yet, and you want to see what this thing is going to do. So I can say, okay, I want to plan it, and you can see that Terraform took a look at the state that it had. Obviously, there was no state yet, so it's going to say, I want to add 2 items. I say, yeah, that looks good, so I can say Terraform apply. What's nice about the plan, though, is that you can save those plans and reuse those plans inside of your CI/CD pipelines. Here, I'm just doing a direct apply, but essentially, you would have, a lot of people like to check in the actual plan files themselves as well. So I'm going to say yes, it's going to go ahead and do the thing. You can see that it's creating the resource group, and then it's creating the static web app. And it pulls, it'll tell you that it's not hanging, so I really like that feedback as well. All right, so you can see that we now have 2 resources deployed. I can go out to the Azure portal and then do the same thing. But one thing here, remember I need that static website, that key for the deployment. So it said that it's sensitive and it's not going to output it, but I can go into the TF state file and I can pull this. So I guess that is kind of a downside that that's not like encrypted on the drive or anything. But there is ways of using different products to store your state in cloud, for instance, and make sure that those types of things are secured. That was only because I was running locally that it was available. So I'm going to go into the Terraform repository, or I'm going to go into the IAC web app repository, and I'm going to reuse that same credential that we used for our previous demo, and I'm just going to go in and update that key so we can reuse that same workflow that was created in the previous demo. So I'm going to use GitHub Mobile and do MFA. All right. So now if you remember that workflow said, okay, I want you to trigger on a pull into main. So I'm going to go in and edit this README, and I'm just going to make a change so I can trigger that pipeline change. So I think deploy the app is what I said. All right, and then I commit the changes, and what that's going to do is it's going to trigger the workflow because it's basically going to execute on the pull into the main repository. So 57 seconds later, you'll see that the workflow completed, and now I can go out to my resource group and see the actual Terraform deployed item, and you can see that, yeah, so I updated the README so that there's no change there, but essentially that's how that happened. So Terraform destroy will actually pull those out as well. It would destroy the items that you have defined inside of the IAC code. All right, so the last one that I want to cover here today is Pulumi. So Pulumi is nice if you are coming from a very developer-focused organization. So this would allow you to do your infrastructure as code using a lot of the most common frameworks. So there could be Node.js, JavaScript, TypeScript, Python, Go, .NET. So that includes C#, F#, VB.NET, Java, and you also have the ability to do YAML. But what's nice here is that, okay, this is more of an imperative nature of IAC, though it does have some declarative features as well. But what's nice is you're using a programming language that you might already be familiar with. So I'm like primarily a Node or a C# developer or Python. So I can go through and I can write this infrastructure as code and have it sit with the repositories into the systems that it's using, and it's using the exact same technologies that I use on my day-to-day basis. So again, you can see in this source code here, it's just your regular C#. So it's running an async method. The first line here says create a resource group called Vanilla Web App Pulumi RG in used US2, then create a static site. So again, these are all just classes, and then all of the programming that you're used to, so this is C# in this specific example here, but you can create classes, class libraries, so anything that you would use in C# you can use for your infrastructure as well using the libraries provided within Pulumi. So let's take a look at what this looks like. So I'm going to go ahead, again, here's our resource group, here's our static web app. It looks great. So let's go ahead and build the project. So I'm going to say, just as you normally would, well, I guess I skipped that step. Typically you would say .NET build. I need to update that demo. And then after you've built it, I have Pulumi, again, is installed on my machine using Chocolatey. So that's available in Terraform. I installed using Chocolatey as well. But then I could say Pulumi up. And what it does is it takes the binary that was created based off of your project build. So again, just a regular .NET build in this case. And it uses that to deploy the infrastructure that's needed. So here's that happening. And then, of course, when we come back, Pulumi is another one that'll automatically create that GitHub action for you as well. So you can see that we have Vanilla Web App Pulumi. And it's probably not deployed yet, so I'll go and check the deployment. And it's still going. 36 seconds later. So I love that, because I would have totally ran out of time doing this live, so I'm glad that the Wi-Fi isn't the greatest. And then I'll go back to my web app, and we can my static web app, and you can see that it did do the deployment. All right, so thank you again for spending some time with me reviewing how to get started with Azure Infrastructure as Code. Again, I want you to take away with you today how it fits into CI/CD, as well as what different tools are available to you. So you got a little bit of a taste for a variety of tools. Again, no tool is bad, no tool is better than the other. Really take a look at your organization and see what fits the best. Thank you.